Chapter 3, Section 2 is about solving linear equations by graphing. So I want to go over first some vocabulary words that you will need to be familiar with as we work through this section so that you know what the problems are asking you to do. The first thing that you're going to hear a lot in this section is function notation. What that means is that you're replacing y in the equation with this new expression, and it looks like this, f parentheses x, but this is read as f of x. So when you see that f with the parentheses x, you're going to hear me say f of x. And it's just a way that we talk about graphs or lines or equations that we're working with. We refer to them sometimes as functions. So they mean the same thing. When you see that f of x, it's the same as it would be if it was just a regular y. And so we're going to go over how to solve something that has that f of x in it first. A parent graph would be a graph that you kind of start out all of your regular functions with. So it's kind of like the original graph that we would have started with before we started adding, subtracting, or multiplying it by any numbers. For example, like the linear parent graph would just be y equals x. A quadratic would be y equals x squared. So those would just be like your plain regular parent functions. And then once we start adding things to it, that's when they start to change. A solution, a zero, a root, an x-intercept, all of these here, they mean the same thing. They all are talking about answers to the problem. So if you're solving for x and you get a number, that would be considered a solution. But it would also be able to be called a zero or a root or an x-intercept. And that's just where the graph crosses the x-axis at. When you're solving a linear equation, like I said, you're going to have some problems that are written in that function notation. So see how this one says f of x equals 2x plus 3. Remember that that is the same thing if I said y equals 2x plus 3. So y and that f of x are interchangeable. We can switch them out if we need to. So in order to solve a linear equation, what you're going to do is replace that f of x or the y, depending on what they give you, with a 0. Sometimes that step will already be done for you, so they might already have it equal to 0. Then you're going to want to solve for x, solving these equations like you did in Chapter 2, using one-step, two-step type setup and problems to get those terms by itself. And then when you get to your answer, so once you get to x equals whatever, that's going to be known as your solution, your root, your zero, or your x-intercept. So let's take a look at this first example. We've got 2x plus 3 equals 0. Now it's already set equal to 0 for us, so I don't need to switch out f of x or y with 0 because it's already got a 0 there for me. So my first step would be to remove that plus 3 by subtracting it. So I would write minus 3, and again, remember, make sure that you do that to both sides of the equation. So over here on the left, the 3 and the minus 3 are gone. So we have 2x equals negative 3. Then I would divide by 2 on both sides. And I would get negative 3 over 2, comma 0, or negative 3 over 2. And the reason why it's written comma 0 there is because if it's an x-intercept, all x-intercepts are written as the solution and then comma 0 because they're on the x-axis, so there's no y movement. It all just stays on the x-axis there. It's not going to move up or down at all, so that's why y is always going to be 0. So to get you guys started on this practice problem, you see the f of x here, so you're going to want to replace that with a 0. So I would rewrite this as 0 equals 5x minus 6. So go ahead and take a minute here and try to solve that problem. So the first thing I would have done is added 6. So then you have 6 equals 5x. Then I would have divided by 5. And I would have just left my answer as a fraction here. So I would have said x equals 6/5, which if you're writing that as a coordinate, remember I said it's always your answer, whatever you got for x first, comma, and then a 0 for the y. All right, so go ahead and take a look at that practice problem and try this one. So for this one, I would have started by subtracting 2. So you have 3x equals a -2, then divide by 3. And so you have x equals -2/3, which again, as a coordinate, would be -2/3, comma, 0. Now let's take a look at this example together. When you see one like this where it's got the variables on both sides, what I would have maybe started to do first is subtract 4x from both sides of the equation here. And when you do that, they're going to both cancel off on both sides. And so you're going to be left with 6 equals -3. That's not true. 6 and -3 are not the same thing. So last chapter we talked about this situation, and that if you ever have this occur where your x or whatever variable it is that they're using is gone and it's disappeared from the problem, that this would then be no solution because there's no value for x that would work to make those two equations balance out. Now let's take what we were learning here and let's apply it to a story problem. So this first one says that Chase's soccer club is selling greeting cards to raise money for new equipment. The cards cost $115. They are selling each card for $1.75. The function y equals 1.75x minus 115 represents the team's profit. Find the 0 of the function and explain what it means. The big important piece of information here is this equation, because that's representing the situation here. Now they just took that information that they gave you, the card cost and how much they're selling each one for, and they put it into an equation for you already. So they did a lot of the hard work for you. I would take that equation, y equals 1.75x minus 115, and I would replace the y with a 0. And then what we're going to do is solve for x. So to do that, we're going to add 115 over first. We have 115 equals 1.75x. Then we're going to divide both sides by 1.75. And when you take 115 divided by 1.75, you get 65.7 for your x. So that's what the 0 would be. But they want us to explain what this represents. So if I were to put 65.7 back in for x here, that is what would make this equation equal 0. So what this means as far as this problem, in order for them to make a profit, in order for them to make money, they need to sell more than 65.7 cards. Now, no one's going to buy a fraction of a card. So really what we could say here is that they must sell at least 66 cards to make a profit. So why don't you read through this problem here and try to solve this one. So again, I would have grabbed that equation that they gave you, m equals 20 minus 0.75 r. Replace the m with a 0. I subtract 20. So I have negative 20 equals negative 0.75 r. Then I divide both sides by negative 0.75. And that got me 26.6 repeating for r. So my 0 would be that 26.6 repeating. And since we're talking about her having money to spend on these tickets, maybe to be able to do these rides, she can't do a partial ride. So what I would have taken from this answer is that she can go on 26 rides. She doesn't have quite enough to do a 27th